Right now we've gone through this worked example 8, which says that let's see, this is a past paper question, right, from the 2010 paper 6-3, and it's question number 4. All right, so let's go. Delip measured the speeds x kilometers per hour of 70 cars on a road where the speed limit is 60 kilometers per hour. His results are summarized by x minus 60. The sum of x minus 60 is equal to 245. So in other words, this just means that the sum of all the speeds that he recorded were actually 60 kilometers per hour less than the real one. Okay, whatever he was using was 60 less than, because this is x minus 60. It's not x. So that means the sum of all the x minus 60s. So it means the sum of all remember that x will be the real one. X is the right one. But here, what he has is x minus 60. So whatever he used was actually 60 kilometers per hour less. I hope that makes sense. Calculate the mean speed of the cars. So they don't want when they say calculate the mean speed, they want the mean, the real one, not the mean of x minus 60. That is not the real one. They want the real mean. So anyway, let's see. Whenever it says find the mean. So we want the mean. But we know that the first thing we can get is, let's first get mean of x minus 60. We can get the mean of x minus 60. What is it? Remember, mean is the sum over the number of terms. So it'll be the sum of x minus 60 over the number of terms. How many cars were there? 70 cars. So over 70, which is going to be, what is the sum of x minus 60? 245. So it'll be 245 over 70. Then we can get the mean of x minus 60, or the mean of all the values that he measured that were 60 kilometers less than. So it's going to be 245 divided by 70. You get 3.5. Okay, you get 3.5. Now, what about the real mean? So mean would be equal to the mean of, it'll be mean of x minus 60 plus 60. Remember that. We just add the 60 to offset it. So then it becomes 3.5 plus 60, which becomes 63.5. Here we have the mean. Now there's a shortcut to doing this. Let's just do it. We could have written it like this. I'll write it in orange. That's what we would have done. To say mean is equal to the mean of x minus 60, which is summation of x minus 60 over number of terms. This is the mean of x minus 60. Then we will add 60 to it afterwards. So we get the mean of x minus 60, then we add 60. So it was just going to be the sum of x minus 60 is 245 over 70. Remember that this part is the mean of x minus 60, right? And then we'll add 60 afterwards. So then say plus 60. We'll still get 63.5. This is a shorter way to write, which can help us when we've got many other situations, right? Let's go to the second part. His friend Sachin used values of x minus 50. So his friend actually had something that was getting 50 less than what it should be. Now calculate the mean again. To calculate the mean. His friend used this to calculate the mean. Now they want the values of x minus 50. They want the sum of x minus 50. All right. So what do we know? We just put it in the formula. We know that the mean is equal to the sum of x minus 50, right, over n, which means this is the mean of x minus 50. Then you add 50. Then you get the true mean. You get the mean of x minus 50, then add 50, you get the true mean. So I know the true mean is 63.5, and it is the sum of x minus 50 that I'm looking for. And I know that there I have 70 terms, and it'll be plus 50. So I'll just take 50 to the other side, make the subject of the formula. So it'll be 63.5 minus 50 is going to be equal to the sum of x minus 50, right, over 70. Then what is 63.5? 63.5 minus 50, I'll get 13.5. 13.5 is, I can now say that 13.5 multiplying 70 is equal to the sum of x minus 50. Then I can say that 13.5 times 70, because 70 comes to the other side to multiply. 945 is the sum of x minus 50. Nothing is hard, is it? Now let's go to the next question. What else do they want? the standard deviation of the speeds. Now they've taught us something about the standard deviation of the speeds is 106. So this is the important formula. Please just master it. That the mean would be the mean of whatever, then plus the correction factor. Okay. If it's mean of x minus some value, you'd say it's the mean of x minus something, then you put plus a. So we can say that mean is equal to the sum of x minus a over n. This gives you the mean of x minus a. Then you add a, right? Then you get the true mean. So that's it, right? That's what you normally get. So now let's go for the standard deviation. It says calculate the standard deviation. The standard deviation of the speeds is this. Calculate the sum of x minus 50 all squared. The standard deviation of the speeds themselves. The standard deviation of the speeds themselves, the x. But we know that the standard deviation of x is also the standard deviation of any other thing. So of x minus 50. So standard deviation of x minus 50. So we can say part 3, we know that the standard deviation of x minus 50 is equal to standard deviation, which is just equal to 17.6 kilometers per hour. Is it 17.6? Am I right? No, 10.6. So now they want x minus 50. So which is 10.6. Okay, which is 10.6 kilometers per hour. So now that means for me to get x minus 50, I'm going to say now that what is the standard deviation of x minus 50? Standard deviation of x minus 50 will be equal to square root of, I'll say the sum of x minus 50 all squared divided by n minus the mean. But we say, remember that it will be what? Remember that it will be minus the mean of x minus 50, right? Remember that it will be minus the mean of x minus 50 all squared. Remember, because we are dealing with x minus 50, yeah? We're dealing with x minus 50. So now let's get that value. We've been told that the standard deviation, so we can say standard deviation of x minus 50, which is also the standard deviation. Standard deviation of x minus 50 is just 10.6. This is equal to the summation of, now we say, what is the sum of x minus 50 all squared? We don't know. Over how many terms do we have? 70. Minus what's the mean of x minus 50? Do we have the mean of x minus 50? I think it's in the question. To calculate the mean, find so his friend Sachin used the values of x minus 50 to calculate the mean. Do we have the mean of x minus 50? Yes, the mean of x minus 50. Do we have it? Sum of x minus 50 is 945, which means we can say that let's first get it, because we found the sum of x minus 50. So we can say mean of x minus 50 is equal to the sum of x minus 50 over the number of terms, which is equal to the sum of x minus 50. We just got it, and it was 945. So it is 945 over 70. Let's get it. 945 divided by 70. Oh, it's 13.5. I think we had this. All right. So either way, fine. Now we can go ahead and we can now say that in here we can would say that the standard deviation, which say we can now say standard deviation of x minus 50 is equal to square root of the summation of x minus 50 squared over n is 70 minus mean of x minus 50, 13.5 all squared. Then standard deviation of x minus 50, we found it to be 10.6 rather. So it is equal to, we can now say 10.6 squared is equal to, so that we take the square, because if we take square root to the other side, it'll become power of 2, right? We will now have summation of x minus 50 all squared over 70 minus 13.5 squared. Then now we take this negative 13.5, so we'd have 10.6 squared plus 13.5 squared now is equal to summation of x minus 50 all squared, all divided by 70. We take 70 to the other side. 70 multiplying 10.6 squared plus 13.5 squared is equal to summation of x minus 50 all squared. Now we can then get our solution. We'll say that 70, open bracket, 10.6 squared plus 13.5 squared. We'll get this is going to be 20,000. It's going to be 20,622.7. This is the summation of x minus 50 all squared. Hooray! Well done! We're done! That's your final solution, right? Is there anything else in the question that we haven't done? Nah, we're done. You can keep doing it and trying it. This is your final solution, and this will be it.